Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. And today also, I'm going to discuss about a very important topics about the quality control, that is standard deviation of concrete cube strength. So what is called standard deviation? How to prepare standard deviation of concrete cubes, what is the normal distribution curve or the bell curve, and why the standard deviation is important. And that each and everything I will discuss in this video. So stay tuned until the get full information about this. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subjects. In a site, we cast the cube and we crush that one to get the compressive strength. So in order to verify that whether my compressive strength is achieving or satisfying the criteria mentioned in the IS 456, that is the acceptance criteria. Now, for that also, we need to determine what is the standard deviation of concrete cube strength. That is why we need a set of data. So IS 456 is saying that minimum 30 samples to be cast and some 30 sample tests to be, the result will be there in order to determine the standard deviation. So you need to have minimum 30 set of data along with you to perform the standard deviation test. And the sample means one sample is equal to average of three individual cube strength is equal to one sample. So you need minimum 30 samples. So before that, we need to know what is standard deviation. It is to be know that is the what is the standard deviation. Standard deviation is a statistical measure to indicate the extent of variation or dispersion in a set of data points. In the context of concrete, it measures how much the compressive strength result of concrete cubes deviate from the average strength. So it is the measurement that we need to know how much percentage of cubes is the below the standard deviation or above the standard deviation. So it is why it is important for the quality control. So what is the standard deviation and how to make, I will come later, but it is a statistical measure to identify the quality control or the strength of the cubes. The next, the standard deviation, to know that we need to know what is the normal distribution curve. Now, the normal distribution curve, also known as the Gaussian curve or the bell curve, is a probability distribution that is symmetric about the mean. In statistic, it represents how data points are distributed around a central value. This shape of the curve looks like a bell, hence it is called the bell curve. See, it is an example of the bell curve. I made it in according to the complete strength of the cubes. Here it is a maximum, that is a mean value. Okay, this is the mean value, it is around count 60. So this is the now in respect to the mean value, how much it is coming in the positive direction and how much it is coming into the negative direction, and what is the standard deviation, that is determine my degree of quality control of the concrete cube. So we need to prepare this bell curve along with the data. So this is the bell curve, is the normal distribution curve. So what is the key characteristics of normal distribution curve? That is a symmetry. The curve is perfectly symmetrical around the mean. So what is the mean? Mean, see here, it is the maximum point mean. So here itself is, this is the symmetry. So the bell curve is always give the symmetric result. Then mean, median, mode. The highest point of the curve corresponds to the mean, median, and mode, which are all equal. So highest point is the curve is called the mean or the median. So 68 to 95 in the 97 rule. What is that rule? This rule described how much of the data falls within a certain number of standard deviation. See, here is the mean. Now my standard deviation is around 60. So my suppose my standard deviation is 5. So 1 sigma is equal to 65, or suppose 2.5. So 1 sigma is equal to 60.25. How much the result will be fall here? And 1 sigma is minus 60 minus 2.5 is 57.5. So how much data will be, or how much result will be there in this area, that is 60% of falls within one standard deviation or mean plus minus 1 sigma. So total number of sets, if you have 100 set of result, the 68% will falls within the plus minus 1 sigma. Then 95 falls with 2 sigma here minus 2 sigma. That within 3 standard deviation. That means standard deviation sigma mean plus minus 3, 3 sigma plus 3 sigma. Here it is minus 3 sigma. It will fall 99.7. And it is tells that the end will never meet the x-axis. It will extend infinitely. If it is makes, that means it's a problem. That is where this normal distribution curve never meet the x-axis. So these are the normal distribution curve we need to prepare when we were preparing the standard deviation of the cube, because with this we need to know how much is my characteristic strength. Now here it is, all we know this, the characteristic strength is fck is equal to fck dot equal to fck plus 1.65 into s. Now why this 1.65 s? Now from this curve already we say that is the 95% around it falls within the 2 plus minus 2 sigma. Now, my degree of quality control is saying 95, 1 in 20. That means 5 cubes can be fail when 100 test. That means if we test 20 cubes, the probability of fail 1 cubes. So if we test 100 cubes, the probability of failing the cube, that is number is 5. So that is why this normal distribution is very important, that we want to know that 1.6 sigma plus minus, it's the area, that is it is 95% of the area of this curve. So it is fall inside the characteristic strength. So now if we are designing for M50 and we have characteristics, we are giving 1.65 into 5, we are assuming that standard deviation is 58.25. So we are designing the 58.25 for the target strength, and we are getting mean maybe 55, 56. So plus minus sigma or the plus minus 1.65, this 95% will fall inside the result that is satisfactory, that is above the 50. If we are targeting for 50, then what will happen? This plus minus 1 sigma, that is separate number of failing chances of the cube will be more if we go for the 50. So that is why this 1.65 is coming from this normal distribution curve or the bell curve. So it is suggesting that the mean is always greater than the mean, whatever my desired strength. If it is M50, it will come around 55. And within plus minus 1 or 1.65 sigma, the 95% will fall in the range that is passed the above the 50 degree 50 MPa. That is why this target mean strength is very much important. That is why this formula 1.65 s is coming. So if we target for the 50, then we'll never achieve this curve and we will never satisfy the criteria. So these are the normal distribution curve and the standard deviation. Now, we need to know why this standard deviation is important. Already I discussed that if it is standard deviation we are not discovering, then consistency. Standard deviation helps evaluate the consistency of concrete quality in batch. So suppose sometimes we are getting standard deviation 3, sometimes we are getting 4, sometimes we are getting 5. What does it mean? That means we are not consistent in order to preparing our mix or preparing the concrete or whatever. We are not consistent. So only way to know the consistency of the concrete strength is to do the standard deviation. Then quality control. Lower standard deviation indicates that the concrete poured is more consistent and reliable, meeting the desired strength and specification. So if my target standard deviation, we are assuming 5 or 3.5 or 4, whatever. If we are getting more, that means our degree of quality control is not that much. If we go with that below, that means, okay, my degree of quality control is good. So it is also evaluating what is my degree of quality control at the side. Then adjustment. If the standard deviation is high, it signals that there may be issues within the concrete mix, materials or production process. So that also we can take precaution or we can redefine the full process to get the concrete as per the requirement. That is why this standard deviation is very much important. Now how to find out standard deviation, that we need to show how to find out. But here it is given the formula in ISO 10262 in 2009. See, here it is also given the number of states in the samples. Total number of states should be a minimum 30. If it is minimum 30, it is not accepted as I discussed. Here it is root over of summation I to n x minus x bar square root of n minus 1, where s is the standard deviation, n is the number of test result considered, x is the average of n number test considered, that is the mean, and x1 is the individual test result. So here it is individual test result, it is mean, and then it is a number of cube. So this from this formula we can find out easily the standard deviation. I will show you one example in Excel. So let me open my Excel sheet. See, here is the Excel sheet. Now we will show you this how to determine the standard deviation. See, here is the compressive strength, individual compression 52, it is for the M50 grade, 52, 53, 1, whatever this is coming. Now here it is the average strength. How we can find out the average? This is the formula we can use here. So it is coming average formula here, average d6 to d60. Okay, we are getting the average formula. Now here average is here. Now what is my formula? X minus x bar we need to find out. So x minus x bar means this minus this. So, and it is x minus x, but it is coming 8.26 and square root of this. So we are getting, so each and every test result, the three samples, here is the individual test. Here it is the average test. Here it is, I'm going taking 60 for the round up, but it is actually coming 59.776 for the round up, and it will give the result here also. So we are taking it a rounded off. Now, here it is standard deviation. We'll find out later. See, x minus x bar means this is this minus this 8.26 and square root this. So here we are getting the x minus x1. Now, here we need to find out summation of x minus x square root over. Here we are getting summation. Now, what is the standard deviation? Square root of x minus x bar whole square divided by n minus 1. So xy mean is 59.7, that is in the average, and it is we are getting the x minus x bar whole square, but this n minus 1. What is the number here we are getting? But you can apply this formula also in the Excel, that is standard deviation p is equal to d6 divided, it is giving you immediately what is the standard deviation. But if you want to make by your own, this is the formula. You first you need to find out the mean, that means average, then you have to minus this x minus x bar and then square root, and then square root y x divided by n minus r. Here it is a 55, that means 55 minus 1, that will be 54. So in this way you can find out the standard deviation. Now I'm getting here the standard deviation 3.109. Now what I consider whenever I'm doing mix design, let's set for example in the IS 262, it is given that for the M50 grade, it is 5. Now I am getting 3.10. So it is below the standard deviation I consider. That means I am getting the standard deviation as per my requirement. But if it is more than 5, that means my degree of quality control is not so much good at the site. That is why we are not getting the right kind of concrete or right kind of the strength. So that is why these standard deviation is very much important. But from the bell curve also you can prepare. I have already prepared here this. For this you need to find out the what is the normal distribution. To make that bell curve in the Excel, first you just to rearrange this data from smaller to bigger. How can I find do that? The short and filter. Here you can short smallest to largest. You should have to consider select all data and then filter from small short a to z, smaller to more. So it will come. Now the normal distribution we have to find out for each and every. So normal distribution formula is you can type equal to normal distribution is given d6 f6. D6 means here it is d6, that means x. Then f6 means average, then G6 means the standard deviation, then false, that means the what will the for normal distribution set that will discover. So in from these two you can create this bell curve. I'm not going on that much of detail. Maybe in another video I will discuss this one. What is the how to prepare the bell curve using the Excel. So here this is the my mean value. Okay, that is 59.7. This is the highest point. Now from here mean plus 1 sigma, that is 59.776 plus 3.109 is coming here, and here is a minus sigma. So 60 by 80% of the cube result will fall on this. Okay, if it is not false, that means my result is not as per the requirement. And here is the mean plus 2 sigma, here it is a mean minus 2 sigma. Here it will fall the 95% of the fault. So in this way, from this bell curve also, you can find out your degree of quality control, the whether the standard deviation you are making as per the requirement or not, or an other word that whatever the concrete we are producing or we are placing, that is as per the requirement or as per the strength criteria. So these are the thing about the all. In the next video I will show you how to make a bell curve in the Excel in details. In this video, if I want to make it, it will be in a bigger one. For today now itself, it's up to this, and I hope you find it useful. And if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notifications. And I'm waiting for your valuable comments so that from your valuable comment, everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. Thank you once again for watching me.